Hello everyone and welcome to Advanced Array Concepts. Disregard week 9 because this is not week 9. These are slideshows that I've put together from previous classes and they come at different points of the game. So just avoid that and not get confused. Alright, so let's move on here if I can move this guy. Alright, so today's objectives in this class, or at least this week, is we learned about arrays, but now we're going to learn about sorting. So we're going to learn about sort array elements using the bubble sort algorithm. You're going to learn about sorting array elements using something called the insertion sort algorithm. Two-dimensional and multi-dimensional arrays. Going to learn about using the array class, the array list, and then enumerations. Sorting. Well, it's just like anything else. It's a process of arranging a series of objects in some logical order. So a good example I like to tell people is think about Microsoft Excel. All right, sorry about that. I lost my mouse for a second here. All right, so this is not working. All right, so sorting is think about Microsoft Excel. You know, you have your columns, you have A, B, C, D, so forth, and you sort items. So just think of that. You're sorting from ascending to descending. So if you have, say you have a mixed numbers, you have 5, 4, 8, 7, 2, 4, whatever. If you sort them ascending, then you have them in ascending order. If you have descending, you have them descending order. So think about that. And I kind of guess I beat my purpose before I got to ascending and descending order. All right, simplest possible sort involves two values that are out of order. Swap two values. So temp equals value A, that's the variable. 16 goes to temp. Just give me an example. Val A equals val B. It's saying that variable is going to be number 2. And then val B equals temp, which is 16. So kind of getting to that is just a way to swap two values around that are out of order. So it's just like if you had... So you had you own a car dealership, and you have 75 cars on the lot, but each one has something specific to it. What would be unique to it? The price value would be one thing that's unique. The year of the model, the year to make the model, whatever. You might have those all in different orders, and you might say, hey, you know what? Give me a list of all the vehicles from 1999 to 2005 that you have on the lot. Now I'm not sure if they have that many vehicles between that year, but let's just say they do because they're older vehicles. They could go and do a sort and say, okay, hey, here's my subset of 6 or 7 vehicles that are from 99 to 2005, and then you might be able to say, all right, also in that order, give me the numbers that has the lowest value, so then you could resort it as well. Bubble sort. So bubble sort, think about you continue to compare pairs of items, swapping them if they are out of order. The smallest item is also known as the bubble to top of the list, eventually creating a sorted list. So for example, we have at the top here, we have 581692. Now we add a unique ID to represent elements. And like I said, I don't know where how much experience you have within software development, or even say if you work with databases or whatever the case is. But I'll use an example for a database. So we all have heard of database. We may have not all worked with a database, but think of this. We go back to the car dealership. Okay, you have your 75 vehicles, but you also need something called a unique identifier. And that unique identifier would be kind of like this right here, 0, 1, 2, 3, 4, 5. So it could be called a row ID, which is a unique identifier. And that unique identifier is always adding up. So let's say we have 75, and let's say every time we sell one, we purge it off the list. So every time we get a new one, that number is going to keep going up. Even if we deleted all 75 and we go to add a new record, guess what? Guess what the new unique ID will be? 76, and so forth. So in this example here, as you see where you have 0, 1, 2, 3, 4, 5. Well, dealing with programming, you always start at 0 to work your way up. So in an array, if you have a list of values and say 0 equals 5, 1 equals 8, you'll never start at 1 or your program will blow up. So we have an example here. These are the unique IDs. All right, so repeatedly compares adjacent items, larger items, bubble rate. So it will look at 5 and 8 first, and if 5 is greater than 8, it swaps, else it stays the same. So I ask you, is 5 greater than 8? What do you guys think? Think about it. Is 5 greater than 8? No, it's not. So what's going to happen is it's going to stay the same. It's not going to do anything. Then what's going to happen in this next slide here is it goes over and compares the next value. It said 5 is not greater than 8, so it's going to go to the next two values. It says, is 8 greater than 1? Absolutely. 8 is always going to be greater than 1. So now what it does is it's going to swap a value. You see where 8 and 1, you'll see in the next slide how they swap over. So if you look here, it was 5, 8, 1. Guess what happens? In this bubble sort, what it does is it moves the 1 over here. Now it's going to do the same thing. So we're going to say, oh, okay, is 8 greater than 6? Absolutely. 8 is always going to be greater than 6. Now this is kind of funny though, because when I was doing this lesson in class, believe it or not, I had 3 people say 8 was not greater than 6. And I think I caught them off guard and they just wasn't thinking right. But anyways, we know that 8 is greater than 6. So what's going to happen here is the 6 is going to go over here and the 8 is going to go over here. So that's what we have. We have 5, 1, 6, 8, 9, 2. Is 8 greater than 9? Absolutely not. So those numbers are going to stay the same. And then what's going to happen here is it's going to say, hey, is 9 greater than 2? Absolutely. 2 is going to move over here and 9 is going to move here. So that's exactly what happened. Excuse me. So now, the original list, look at the original list. It was 5, 8, 1, 6, 9, 2. But we went and said, hey, is 5 greater than 8? No. So 5 stayed there. And we said, is 8 greater than 1? Absolutely. So 1 moved over here and 8 went here. 8 was greater than 6. 6 moved over and 8 stayed. 8 is less than 9, so it's not greater than 9. It stayed. And then we did 9 is greater than 2, and it swapped. See, the smallest item didn't work. It's way all the way to the left. The largest item moved all the way to the right. So the second iteration, we will only review 0 through 4 because 5 is what we wanted. See, the smallest item didn't work. It's way all the way to the left, as we mentioned. So that's kind of how that sort works. It's kind of how the highest number ended up over there. All right, so your second iteration is, okay, 5 is greater than 1. Absolutely. So now it's going to do a swap. I'm kind of go through this because we've kind of talked about it. Is 6 greater than 8? No. Now is 8 greater than 2? Well, absolutely. So it's going to move over. Now, as you see here, second iteration completed with 8 moving to the far right. We need to continue until we have 1, 2, 5, 6, 8, 9. So you kind of see where we're going here. We want the lowest numbers. So we want it in ascending order. We want the lowest to the highest. So eventually we want this to be our value, and it'll keep doing it until it's completed. So now the sort is completed. We have 1, 2, 5, 6, 8, 9. Now if we wanted to do it descending, then the same thing would happen, and those numbers would go over here, and we'd have 9, 8, 6, 5, 2, 1. So hopefully that made sense, how the sort works. So the sorting array of objects. Bubble sort is not an efficient sorting algorithm because it uses nested loops. It is useful only for small data sets. So it runs O with n to the 2 power, and the big O, or n squared, is running 9, or running time. Duh. So in this example, you have I is the outer loop and J is the inner loop. And then you have the 1, 5, 2, 6, 8, 9. So how that works is J goes from 0 to 2 in this iteration. So you see where J and J plus 1. So in coding standards, you'd have your declaration of a public integer, a bubble sort, integer list. I can't talk. And then at the bottom here, we have a return list. So how this works is I equals inner loop, J equals outer loop, and temp equals doing swaps. So we declared integer I, j, and temp. And then we talk about the outer loop is going to run from 0 to the length of the array in the for statement. Then the inner loop is going to run from 0 to the length of the list minus which number of items that have been sorted. So I is the number that has been sorted. Which are the number of iterations that we have completed. So we have for j equals 0. J is less than the list.length minus 1 minus I value, and then the j++. So as you move down here, we're going to compare items from left is greater than the item on the right. We want to swap items around. See, kind of getting to this bubble sort, just going through it and me talking about it, it's confusing. It's not the easiest sense. And when you're writing code, so you might, like for example, you might go for a job interview and they're going to say, hey, say your name's Jeff. They're going to say, hey, Jeff, can you sort numbers in Java code? Absolutely. Can you tell me how you would do it? Then say you go and put this bubble sort because it's the only thing that could come to your mind. You know the next question is going to say, is that the quickest way? You're going to say, absolutely, because you don't want to get into the conversation of that there is another way, it's quicker, but you don't remember it. But be honest with them and say, yes, there is another way. It's called this, but at the time I can't really think about how it works. You could start writing something, and they'll more likely they'll reach out and try to help you complete the thing, the scenario. But what you don't want to do is you don't want to get caught in line because they're gonna be like, oh, hey, how about this algorithm? Blah blah blah. So trust me, I've been there when I did the Google interview a couple years ago. Anyways, back to this. So for a equals 0, so it kind of goes down as continued as we talked about. Using the bubble sort algorithm, it keeps going on here. As you see here, it's doing the for loop, if conditions, and it just keeps loop until its comparisons have been made. So you can sort arrays of objects in much same way as the sorting array, but the major difference is to make the comparison determines whether to swap two array elements, sort based on a particular object. So bubble sort, not the best way. The other sorting way that we talked about, this one right here, it's not the quickest, but it did work a lot better than that one. The next one we're going to get into is insertion sort. So a sorting algorithm that enables you to look at each element one at a time. So you can move items down if the tested element should be inserted prior to other elements, similar to the technique that sorts a group of objects manually. So you have a detailed look at how your insertion sort works, the big O analysis on running time, some sample code, and examples at items with integers. So sort all items to left or smaller. 581396 we start off, and then we have our little unique ID values at the top. So now we start off as k is key value. Is k less than 5? So we're going to play the same game that we did before. We did greater than. It's going to be the same revolution, same scenario, 5 and 8. As you see here, it's going to go back and forth. We now go back to k. Is it less than 5? As you see, I won't go through that manually, but you'll see how that works. We want it. It started off at 581396, and as you see, it ended at 135689. It did the same sort that we did earlier. Is this number greater? But this time we said it's less because we want the smallest number first. So an insertion sort is not a fast sorting algorithm because it uses nested loops to shift items into place. It is useful only for small data sets. Once again, if it runs O n to the 2 power. So now we have Java code. Let's see here. I equals 1 to 5. I equals 1 to 0. It's going to be a little bit quicker. Same scenario. Here's your source code. You're declaring your variables. You have a for loop and a while loop. So the for loop is going to say, do for, run this, while this equals this, and this equals that. And it's just going to keep coming. Eventually return that list at the bottom. And here's just an example of some source code doing the same thing. So it starts off where it has int some num. So it has this array list right here with these values in it. It says a equals 1, and it says while a is less than one of these guys up here. So we're going to say, hey, while a is less than, this value is always going to be less than these numbers. Well, actually, 1.length. All right, so what it's going to do is say some nums.length. So it's going to take this number, the length of it is 2. So it's going to say this equals 1, and say is a less than 2? Is 1 less than 2? Absolutely. This value is always going to be less than these guys because it's 2 length, 1, 2, 1, 2, and so forth, and this is only 1. So now it's going to say temp equals some num a. So it's going to have some num a equals 1. Let's say b equals a minus 1, while all it is conditional statements, as you see here. Adds it up, and then it keeps populating it and just displays it. So any questions? I know you can't ask me right now, but we're at this point, we're on page 39 of the chapter using two-dimensional and other multi-dimensional arrays. You shoot me an email, text, whatever, and say, hey, you know what? I can't figure out what you were just talking about when we go through it. So one-dimensional or single-dimensional array. An array that you can picture as a column of values. So once again, go back to Excel. Row A, values. Elements are accessed using a single subscript. Two-dimensional arrays have 2 or more columns of values. Have rows and columns, use subscripts, and are also often known as a matrix or table, and going back to Excel. So this one right here is using a multi-dimensional array. So you have the integer some nums, you have these 2 brackets. You have to have 2 brackets because you're creating a new class, a new value, and you're calling it int, and you're giving it 3 and 4, and it's going to match these 2 guys right here. So we have some numbers 0, 0, 0, 1, so you can have multiple values in here. So think of this as, let's say that you have, let's see here, all right, so you have 5 baseball cards, 3 baseball cards, and each baseball card has a value. So we know that 0 is the Roberto Clemente card. We know that when you get down to value 1, it's the Babe Ruth card. Number 3 is going to be the Honus Wagner card. Number 4 is going to be the Ted Williams card, and so forth. So once you get to 0, you're going to say, okay, that's Clemente. 0 on this side might not be Clemente, it might be Ruth. Over here, number 1 we know might be Barry Bonds, and 0 over here might be someone else, and so forth. Those are two-dimensional arrays. Using two-dimensional other ways, same thing. So we have int rents equals 400, 450, 510, and so forth. It's going to do the same thing for values there. So pass an array name just as you do with a one-dimensional. So we have public static void, display scores. You have your double int for 2 different things in score arrays. So you're going to pass a value here and a value there. So you're going to do like 5, 7. This is what you can use when using one of the sorts we discussed today. See, the length of the field holds the number of rows in the array. So you have to think about what's the length. So if you have 5, 6, 7, what's the length? 3. 5, 2, 2. 5, 1. Hopefully you get that. So, see, that's funny. I use that as an example. This is a two-dimensional array. Yeah, on this I got this directly from Excel. And there's a 0 column I have Pittsburgh, and then 1 we have Pirates. So we have the city and then the team in the next column. And that would be an example of a two-dimensional array. So write a two-dimensional array that supports baseball teams on the previous side worth 5 points, time 30 minutes. Well, disregard this because this is something that we did in class, and I don't expect you to do it online. So I'd say ignore it, but you know what? If you want to give it a shot and see how you could do it. Ragged array, a type of multi-dimensional array. A two-dimensional array with rows of different lengths. So ragged, that's where you get it. It's not the best thing. It's crazy. So to create a ragged array, define the number of rows for a two-dimensional array. Do not define the number of columns in the rows. That'll just make it too complicated. Then declare the individual rows, and also known as the jagged array. Of course, that would be a name from it. A name from Pittsburgh. So here's an example. We have a public static void main. I started up here. We have int jagged array equals 1, 2, 3, 4. Second one is 5, 6, 7. The third row is 8, 9, 0, 1, 2. Then we have a null. We have a 3, 4. And they kind of follow in this sequence right here. So we have this. You see how we have these values, and we'll have 4 values over here. Here we'll have 3 values. Here we'll have 5 values. Here we'll have a null, and here we'll have 2 values. So you'll be able to use multi-dimensional arrays. So those are good examples of how you can store multiple values in there. So what value will print out if we use row 1 and element 2 here? That's another in-class one. So I would say take this right here and play around with this. I'm not going to tell you what the answer is, but plug it into your clips. Write a new static void main, write this code in there, and see what you get, and see if it's exactly what you thought it was going to be. So multi-dimensional arrays. Arrays with more than one dimension, create arrays of any size, keep track of the order of variables needed as subscripts. Do not exhaust your computer's memory. Okay, here we go. All right. Array class contains many useful methods for manipulating arrays. Static method. Static is what you think it is. It doesn't move. It doesn't change. It stays the same. Binary search. Remember binary search. It's very popular. It's that's the thing that got me on the Google interview. But nonetheless, forget about the Google interview. Binary search is fast. It's a convenient way to search through sorted lists of values in various data types. The list must be in order. I'm not going to go through this, but you can look at this in your book. It'll show you about the methods and the purposes that follow with it. This right here is a good example of code. This is also found in Figure 915 in the book. The arrays demo application, you could kind of go through it, look at it and see what it's doing. I'll kind of skip through that right now. For now, we'll kind of get into the coding part of it when we get into the lab work. So the ArrayList class provides some advantage over array class. Dynamically resizable, can add an item to any point of an ArrayList container, can remove an item at any point. Then you get capacity. What's capacity? Number of items in an ArrayList. So capacity is how much it can hold. Once again, I won't go through this. It just gives you some methods about adding, removing, setting, and so forth. Same thing here with the code. I'm not going to go through this right now. Enumerated data type. It's a create a data type within a fixed set of values. So to create an enumerated data type use a keyword enum or enum, an identifier for the type, a pair of curly braces that contains a list of the enum constants. So in this case, it's saying enum or enum month. And it gives you January all the way to December. We could do something else. We could say enum days of the week. And then we'd have Sunday all the way to Saturday. So hopefully that makes sense. Oops. Going backwards. I'm going to skip that. Creating enumerations. You can declare an enumerated type of its own file. Starting with Java 7, you can use a comparison operator for constants. Skip that. Advantages of creating an enumeration type. Only allowed values can be signed, so you tell which ones you want to sign. Provides a form of self-documentation. Can be used for add methods, other fields. Type safe. Describes a data type for which your appropriate behaviors are allowed. In this code right here, you see where we have the enum property, single family, multiple family, condo, land, and business. Setting up an array there. Does the public main, then it declares property equals property.multifamily. And then it's doing a switch. And switch is just another way of doing an if statement, but a little bit fancier. It says case single family. What case single family means, if the value is single family, then it's going to stay there, else it's going to move on to the next one. We talked about bubble sort, insertion sort, two-dimensional arrays class methods, and creating enumerations. Things you want to look at if you don't do. Summary here. What we talked about. And that's it for this chapter. So that's about 26 minutes talking. So I'll give you a few minutes back to your time. It's not as long as before. What we'll do in the lab work, we'll go through some of the things that we skipped over, which is the coding exercises. All right, thanks a lot for listening. Have a good day.